Good day, ladies and gentlemen. Welcome to Code Switch in 2020. Today we continue with our grade 11 physical sciences, looking at the application of Newton's law. Without any waste of time, let's look at today's question. Please pause the video, attempt the question, and continue the video and check if your answers is correct. So today's question states the following. A girl is pulling a 40 kg box with a rope that forms a 45-degree angle with the horizontal. If she applies a force of magnitude 110 Newton and there is a frictional force of magnitude 10 Newton, then question number 1 states, draw a force diagram. Number B, draw a free body diagram. Number 3, determine the box acceleration. So let's try to draw our box. This is our box. It's a 40 kg box. And they say the girl is pulling it at an angle to the horizontal. Meaning if this is our horizontal, then she's pulling it at 45 degrees. With the applied force of 110 Newton. And there exists a frictional force of 10 Newton. So this will be our box. Then question number 1 says, draw a force diagram. For us to draw the force diagram, let's draw our diagram first. And we need all the forces that are acting on the box. This will be our 40 kg. Supposed to be kg here. So how many forces are acting on this diagram? Number 1, because of this is on a horizontal surface, we have the normal force. We have Fn. And we have Fg, which is the gravitational force. And since our force is not moving up and down, then our force will be balanced. And we have a force that is acting on an angle to the box, which is 45 degrees. This is our 45 degrees. Then this is our applied force. And we also have a frictional force. These are the forces that are acting on the diagram. Then since the magnitude of the applied and frictional force is given, you can write them. Then say this is 10 Newton and our applied force is 110 Newton. This is our force diagram. Number B, it states that draw a free body diagram. We know that a free body diagram is represented by a dot. Our diagram is a dot now. The dot represents the object. So all the forces that are acting on the box is still Fg, the gravitational force. And we still have normal, which is Fn. And we still have a force that is acting at an angle of 45 degrees. This is our applied force. This is 45 degrees. And we have our frictional force of 10 Newton acting in the opposite direction. Then we can put our magnitude. This is 10 Newton. This is 110 Newton. So that will be how to draw our free body diagram. Let's look at number 3. They said determine the box acceleration. Number C. We know that according to Newton's law, the resultant force will be equals to, I'm writing FF. According to Newton's law, it says FR is given by MA. And FR is our resultant force. How many forces are acting on the box? It is the applied force and the frictional force. And since this is acting at an angle, we need the horizontal component of our applied force. And if we complete our diagram like this, for us to get the horizontal component, it will be Fx component will be given by the force applied multiplied by the cos of theta. This will be our horizontal component. What is the magnitude of the force applied? It's 110 multiplied by the cos of theta, which is 45. Then what is the horizontal component? When you punch on our calculator, we get 77.78 Newton. Then after we got our horizontal component of our applied force, we can say now FR equals to MA. Then the resultant force is the horizontal component of the applied force minus the frictional force, which will be equals to MA. Our horizontal component, we calculated it and we got 77.78 minus the frictional force, which they said is 10 Newton, equals to M, which is our mass of 40 kg multiplied by the acceleration. Then to get our acceleration will be equals to 77.78 minus 10 is 67.78. Then we divide both sides by 40. We're going to get 67.78 divided by 40. Then this will be equals to 1.69 meters per second squared. So what we're supposed to do is we're supposed to choose a direction. Let's set our direction to the right is positive. So since the acceleration is a vector, it must have both magnitude and direction. Then we said is 1.67 to the right, since our answer is positive. So let's just do a quick review. To Today's question stated the following. A girl is pulling a 40 kg box with a rope that forms a 45-degree angle with horizontal. If she applies a force of magnitude 110 Newton and there is a frictional force of magnitude 10 Newton. Number 1, draw a force diagram. Number 2, draw a free body diagram. Question 3, determine the body's acceleration. So for us to be able to draw a force diagram, we need to know all the forces that are acting on the box. Then we said is the applied force of 110 Newton at an angle of 45 degrees. Then we draw it. Then the frictional force that is acting horizontal in the opposite direction of 10 Newton. So for us to draw the force diagram, we said since our box is not moving up and down, the gravitational force and the normal force balances. We draw the both of them. Then we said force acting at a 45-degree angle is our applied force of magnitude 110 Newton. Then after we said the frictional force that is acting horizontal in the opposite direction, it's 10 Newton. Then this is our force diagram. Number 2, they said draw a free body diagram. A free body diagram is the object is represented by a dot and all the forces acting on the object are the normal force, gravitational force, frictional force, and the applied force at an angle of 45 degrees. Then the last one said determine the box acceleration. Then to get the acceleration, we need the resultant force equals to ma, according to Newton's law. Then for us to get all the horizontal forces acting, we needed the x component of the applied force. Then we applied our right angle triangle here. Then we said horizontal component will be Fa, which is the applied force, multiplied by the cos of theta. Our applied force is 10 Newton, the cos of 45 degrees. Then our answers, we got 77.78 Newton. Then we said Fr equals to ma, which is mass multiplied by the acceleration. All the forces acting is the x components minus frictional force. Since our Fr is going to the right is positive, it's positive, then negative Fr. Ff, which is the frictional force, equals to ma. Then we did substitution, which is 77.78 minus 10 Newton, all equals to 40 kg multiplied by a. Then 77.78 minus 10, all divided by 40, you got 1.69 meters per second to the right. That's our acceleration. Thank you for watching. For more videos, please go to Code Switch in 2020.